Hey guys, welcome to another online math class. This lesson will be about arrays, and hopefully by the end we'll know what with and without replacement means, be able to create an array, and finally use an array to calculate the probability. Alright, so let's just pause the video here and take a couple of minutes to write the learning intentions and success criteria down. Alright, so let's start off with what an array is. Alright, so an array looks something like this, and it is a table that shows the possible outcomes or the sample space of a two-step experiment. But before I go into the key features of an array and how to create or use one, I just want to go through what with and without replacement means, as you can see over here. Let's start off by going through a sample scenario. Let's say you are given 3 individual cards with the numbers 1, 2, and 3 on it. Let's say that's the front at the top and that's the back at the bottom. All the cards are placed face down and you pick 2 of the 3 cards at random. And we need to draw an array with replacement and without replacement. So after you're given these 3 cards, you need to pick one card first. So when we pick one card, we're going to take one. Let's say we picked the 2. So we took the 2 away there. In a scenario with replacement, we would put that card back and then pick another number again. So you might pick 2 first and then 2 again, which will be represented as something like this. So that means you pick 2 the first time and then you pick 2 again the second time. However, if we did this without replacement, let's say we picked the 2 the first time and you wouldn't put it back, you just pick up a card depending on what's left there. So you could only get something like 2, 1. So you pick 2 the first time and you pick 1 the next time, or you might get a 2, 3. So you can never get a 2, 2 if it's without replacement. Alright, so hopefully that made a bit of sense on what with and without replacement is. If it didn't quite make sense just yet, just feel free to ask me in the Google Meets. Alright, so now we know what these two words mean. Let's have a go at making an array. So an array just shows us all the possible outcomes in picking 2 cards. Let's start with replacement. So we need to make sure our array shows that it's with replacement. So just write that up the top, with replacement. And over here, let's say our columns is going to be first. That's our first pick of the cards. And on the rows, let's say that's our second pick of the cards. And also need to show the cards that can be picked. So that's card 1, 2, and 3. And in the columns as well, our second draw 1, 2, and 3. So let's just separate those two by starting to draw a table there. Alright, so just make sure your first pick goes into the first part of the outcome and your second pick goes into the second part there, like that. And here, if I picked a 2 first, I might pick a 1 next. And this means I picked a 3 first and I picked a 1 next. So there's a little bit of a pattern here. I can just fill out this first column with all 1s there. I can just make this all 2s and I can make that all 3. And I could fill the next part out with 2 there, close the bracket, 2 there, close the bracket, and 2 there, close the bracket, and 3, 3, and 3. So these are all the possible outcomes of the cards that I pick with replacement. So this one here, let's look at that one. That one means I picked a 2 first and then I picked a 1. This one means I picked a 3 first and then I picked a 2. That one means I picked a 1 first and then I picked a 3. So an array is just pretty much the sample space of all the possibilities. Alright, so that's an array with replacement. Let's try without replacement now. So our format's going to be exactly the same as before. We're going to label it without replacement up the top. And then I'm going to put first pick along the top again. So first and then second there. And then just write the cards that we can pick across the rows and the columns there. And it should look something like that. Alright, so for without replacement, if I pick a 1, I can't pick a 1 again because I've already picked it and we're not putting it back. So that means I'm going to put an X there because we can't have that option. We can pick a 2 and then pick a 1. And we can pick a 3 and then pick a 1. That is possible because we're not picking the same one twice there. Next one, we can also pick a 1 and then pick a 2. That's fine, but we can't pick a 2 and then pick another 2 because we're not putting the 2 back. And we can pick this one as well. So that'll be 3, 2. And next one, we can pick a 1 and then a 3. That is possible. I can also pick a 2 and then a 3. But I can't pick a 3 and then a 3. That's not possible. So that is what your array would look like without replacement. So if we have a quick look at the array from before, we can see that our total number of outcomes is 9. So your probability when not simplified is going to be something out of 9. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9. But in the next one without replacement, there's only a total of 6. 1, 2, 3, 4, 5, and 6. So your probability as a fraction when not simplified will be something out of 6. Alright, so hopefully now you guys have a better understanding of what an array is and how to create one. Let's have a go at an example problem here. So we have a fair 6-sided dice is rolled twice. So when working with dice, it's always going to be with replacement, because when you roll a 1, on your next dice, the 1 isn't going to disappear. It's going to be possible to roll a 1 twice. Let's start by drawing out a table. So I'm going to label the top as roll 1 and the side as roll 2, like that. And our possible numbers are 1, let's do that again, 1, 2, 3, 4, 5, and 6. And I'm also going to have the same going down, 1, 2, 3, 4, 5, and 6. And let's fill out the rest of this array now. So once again, just a quick shortcut, I can fill out the first column and the first part of this outcome with 1s, just like that. Just go all the way down, and the next one I can fill the first part with the 2, just like that. Alright, so by now your array should look something like this. Notice the pattern, the first part is just 1s here, going down, next is 2s, next is 3s, 4s, 5s, and 6s, so on. And the next part can do the same thing going horizontally. So this one, there'll be 1s, all like that. Go all the way across, just close the brackets off as you go, and the next one will be 2s. And it'll be exactly the same thing for the rest of the numbers below. So now your array should look something like this. Alright, there's just a neater one for you guys to look at or copy down. And if you got that, the first part of your answer will be correct. So that's question A, list the sample space using a table. Next question is to state the total number of outcomes. So I did an example before over here. We said the total number of outcomes was 9 here. In this case, you could just do 6 times 6. So the total number of outcomes here will be 36 outcomes. Next one, question C, find the probability of obtaining the outcome 1, 5. So that means I roll a 1 first and then a 5. And out of the total, there's only 1 there. So your probability there is going to be 1 out of 36. Alright, question D, let's start with that. So it says find the probability of rolling a double. So question D, part 1. So let's start doing that. A double, let's circle all the doubles. I can see 1 there, 2, 3, 4, 5, and 6. So there's a total of 6 doubles out of a total of 36 outcomes. Let's simplify that, divide both the top and the bottom by 6, and that gives you a probability of 1 out of 6. Our next one is part 2 of question D. That's to find the probability whether it makes the sum of at least 10. So that means after rolling the 2 dice, the outcome has to be more than 10 or 10 or more. Alright, so I can see this one, 4 plus 6, that equals 10, 5 plus 5, that equals 10, 6 plus 4, that equals 10. Add these two together, 5 plus 6 and 6 plus 5, that gives me 11, and 6 plus 6, that gives me 12. All the ones on this side of those circles, so that side there, like that way, they are smaller than 10, so they don't count in my count. And I can see there's a total of 6 there as well, so it'll be 6 out of 36, which also equals 1 out of 6. And last one is the probability that the sum does not equal to 7. So that's question D, part 3. So I'm going to start by circling all the ones that do equal 7. So that's going to be all of these here. 6 plus 1, that's 7. 5 plus 2, that's 7. 4 plus 3 is 7. 3 plus 4 is 7. 2 plus 5 is 7. And 1 plus 6 is 7. So there's only a total of 6 outcomes that equal 7. So I can do 36 minus 6 to find out how many that don't equal 7. So that's going to be 30 out of 36. And I can simplify that again, divide both the top and the bottom by 6. And that will give me a probability of 5 out of 6. Alright, last one, we're tapping back into a bit of conditional probability, is find the probability of a sum of 12 given that the sum is at least 10. Alright, so the sum of at least 10, they were these ones over here. I'll just circle them for you again. So these 6 here. So that means our probability is going to be out of 6 because there's only a total of 6 possibilities there. And out of these 6, there's only 1 with a sum of 12. So my probability for E is going to be 1 out of 6. Alright, now it's your turn here. Have a go at this one. It's very similar to the one before. And just unpause it when you're ready to go through it with me. Alright, so for this question, if you haven't noticed already, it's going to be the exact same array as the one we just used. Alright, so using this array, let's start with question A. Find the probability of obtaining the outcome 6, 4. Alright, so 6, 4, there's only one possible outcome there, so that's that one there. So it'll be 1 out of 36. Alright, next one, question B, part 1, is find the probability of 3, 2 or 2, 3. And these are these ones just there. And there's only a total of 2 outcomes out of 36. Alright, and I can simplify this because both the top and the bottom are even numbers. I can divide them both by 2. 2 divided by 2 gives me 1, and 36 divided by 2 gives me 18. So your probability there will be 1 out of 18. Next one, question B, part 2. Find the probability of the sum of at least 9. So they need to equal at least 9 when I add them together. And these ones are all the numbers that are on this side of the line. So these ones and all these there. Alright, so if I count them up, I'm just going to keep the line there and rub the rest out. If I count them up, there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's a total of 10 out of 36. And once again, since they are both even numbers, I can divide them both by 2. So that gives me a probability of 5 out of 18. And last one, probability that the sum is less than 4. This one's going the other way. It has to be less than 4. So it doesn't include 4 as well. It has to be less than it. So that's going to be all these numbers there. So that's a total of 3 out of 36. And both 3 and 36 can be divided by 3. 3 divided by 3 is 1. And 36 divided by 3 is 12. Alright, so give yourself a tick as you go for each one you get correct there. And if you're struggling, you just ask me in the Google Meets. And last one, question C, find the probability of a sum of 3 given that the sum is at most 4. Alright, so that means in the bottom part of my fraction, it includes all the numbers that add up to at most a 4, sorry. So at most a 4, that are these numbers on this side, so all these numbers. Anything on this side will not count because they're bigger than a 4. We don't want anything bigger than a 4 here. Alright, so at most 4, that includes 1, 2, 3, 4, 5, 6. So it's going to be something out of 6. Just write that in there. And out of these numbers, we need to find the numbers that add up to 3. So there's going to be a total of 1 and 2 there. Only these two numbers from those add up to 3. So that's going to be 2 out of 6. And once again, they're both even numbers, so I can divide them both by 2. And that gives me a final fraction or probability of 1 out of 3. Alright, so give yourself a tick if you got that one correct as well. Alright, so that's with replacement. Let's have a go without replacement now. So we got the word kick here, and we're choosing 2 letters from the word kick without replacement. Alright, so let's start off by drawing an array. So I'm going to have my first pick on the top, second at the bottom, and our words going across. I've got K, I, C, and K. And same thing going down, K, I, C, and K. And I'll just make it look like a table there. And this is without replacement, so I can't have any double ups. If I pick a K, I can't pick a K again. If I pick an I can't pick an I again. If I pick a C, I can't pick a C again, and same with the final K. Alright, so let's fill this out with our shortcut. Going down, I can just fill all that with I's. Going down, I can fill that with C's. And so on. So once you've done that, your array should look like this. And then I'm going to go across and fill all these with K's, all these with I's, and so on. And that's what your final array should look something like. And that's just an easier version for you guys to read. Alright, let's have a go at finding the different probabilities now. So question B, find the probability of obtaining the outcome KC. So there's 1 there, and there's another one here. So this time there's going to be 2, and we need to know the total as well. So if you counted them up, you would count a total of 12, and that can be simplified to a fraction of 1 out of 6. Alright, next one, selecting 2 K's. So your outcome is going to be KK. There's that one there, and there's that one there. So once again, that's 2 out of 12, which also equals 1 out of 6. And part 3 is the probability of selecting a K and a C. So this time it doesn't give you an order. So it could be in any order. It could be that one, could be that one, could be that one, or it could be that one. So this time was a total of 4 out of 12. And if you simplify that, divide both the top and the bottom by 4, that gives you a probability of 1 out of 3. And last one, part 4, question B, is the probability of selecting 2 k's given that at least 1 k is selected. Alright, so we need to start off by finding the bottom part of the fraction. So we need to find all the ones that have at least 1 k selected. So there's 1 k, there's 1, there's 1, there's another 2, there's another 2, and there's another 3 there. Alright, so there's a total of 10 outcomes with at least 1 k selected. And out of these, I can see 2 options where there's 2 k selected. So that's just these 2 there. So my probability is going to be 2 out of 10, which simplified becomes 1 out of 5. Alright, now moving on, it's a very similar question again. Your turn here, pause the video here, have you got this one, and just unpause it when you're ready to go through it with me. Alright, so first step is to create an array. So first pick up the top, second at the bottom, I have something like that. And it says of the 4 cars, 2 are red, so I could pick, our options are red, red, 1 is blue, and the other is white. So same thing going down as well, red, red, blue, and white. Alright, so once again it's without replacement, so I can't have any double ups. So I'm just going to start off by putting x's diagonally. And let's fill out the rest of this array here. And that's what your array should look like. Give yourself a tick if you got that correct. Alright, part B is to find the probability of obtaining a red car first and then a white car. So that means it's going to look like this, red and then white. That's meant to be an R, not a K. Alright, so I can see 1 here and 1 there. So there's going to be a total of 2 out of 12 because there's a total of 12 outcomes there. And if you simplify that, that's going to be 1 out of 6. Alright, next one, selecting 2 red cars. So that's part 2 of question B. Start by rubbing out these 2 circles. Selecting 2 red cars, I can see 1 up here and 1 there. So once again, that's 2 out of 12 as well. So I should write probability of red, red. That's going to be 2 out of 12, which equals 1 out of 6 as well. Part 3, selecting 1 red car and 1 blue car. So the order's not there. So it could be in any order. So just make sure it's got 1 red and 1 blue. So I can see 1 here, 1 here, 1 here, and 1 here. That's a total of 4 out of 12, which equals 1 out of 3. And part 4, selecting 2 red cars given that at least one of them is a red car. So on the bottom part of the fraction, it's going to have all the possibilities of selecting 1 red car. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 possibilities of at least selecting 1 red. And out of these 10, there's only 2 options that have 2 reds. So it's going to be 2 out of 10, which also equals 1 out of 5. Alright, so give yourself a tick for each one you got correct there. Otherwise, that brings us to the end of this lesson. Hopefully you guys do have a better understanding of arrays, know what with and without replacement is, can create an array, and also can use an array to calculate the probability. Alright, thank you guys for watching, and I'll see you guys all back online.